Welcome to this, a beginner's guide to FreeCAD. As well as teaching some of the basics of using FreeCAD, this will create something that's practical, a 3D printable baseboard for placing a breadboard for creating electronic circuits with the ability to connect to a power supply using banana plugs. It'll use two different techniques in this. One is create a basic 2D shape that we're going to extrude or pad, as to use the FreeCAD term, and the other is one that we're going to revolve around itself to create the legs. This is what the finished product will be like. As you can see, it just places a breadboard on a board with the sockets on the top for connecting to a power supply. I find this very useful because I have a bench power supply and it makes using the breadboard and testing much easier and simpler to use. So what's FreeCAD? FreeCAD is a free and open source computer-aided design program, as its name suggests. Specifically, it's a parametric 3D computer-aided design modeler. Now the parametric part means that it's driven by dimensions. In the case of FreeCAD, you have to plot everything down very specific in terms of where it's going to be. This is particularly useful for projects such as this, where distance and dimensions are important. If you're looking for more of a free flow type 3D drawing tool or something like that, then there are other applications such as Blender that could be used instead. But this is the sort of thing that FreeCAD works really well with. I'm going to start by creating the baseboard. I'm just going to create a new file. One of the things to note is that FreeCAD is based around workbenches, and there's various different workbenches that you can use here. We'll only use a very small subset of these. To be honest, I've not used many of them myself. The main ones we will be looking at is part or part design and then the sketcher, but we'll switch to those automatically really. So we'll just go straight into part design, and you see there's the tasks. You have to create a body first and then create a sketch. Everything is based around sketches, or everything we'll be creating will be starting with a sketch and then turning that from a 2D sketch into a 3D model. The first thing you have to do is choose which plane you're going to be on, and it defaults to the X and Y plane, which is correct because that's as though you're looking down on the top, and that's what we want for this particular one. So go for the X and Y plane, and then we're into the sketcher tool. So although we started with part design, you can see the workbench has changed to the sketcher, and basically the different workbenches, what they do is they change your tools along the menu system. We're going to start with a basic rectangle. So that's one of these tools here. You see these are the drawing tools. So just draw a rectangle. You have to click it twice, once for the start and once for the stop, the finish point. Now there's a rectangle. Remember I said this is a parametric drawing tool, so it's going to be rather fussy about what you can see. So I'll just right click to get rid of that. And it says here that it's under constrained, and under constrained means that you've not defined all the dimensions. As you can see, we can move it, we can change its size. So what we need to do is we need to lock these down. One thing it has done, so this is done by using constraints. These are the constraints here. This second menu bar we're going to be using, and here's the details here of which constraints you've added. And in this case, it's already put these parallel constraints in. And what that means is that these lines will stay parallel, so we don't have to worry about them skewing off. That's been added for us automatically. If you draw a straight line, then it tends to add one of those in already, the horizontal or the vertical one, or you can apply that separately. What we want to do is basically we want to define some dimensions here. And so if we click that first line, I've already worked out the dimensions I wanted. I want the horizontal dimension. We're going to fix that at 120 millimeters. Okay, zoom out a bit, so that's quite big. And then we can do the same for the vertical. I wanted to set this at 110. You can do that just by clicking on there, same as we did there, and click on the vertical. Just show you the alternative is just click on the points at the corners. As if you hold the shift key down and then click on that, and it does exactly the same. So we want to that 110. And I'm just control and using the roller ball to zoom out. Now if we look at the constraints, it says it's still under constraint with a 2 degrees of freedom. What we've done now, we've fixed the lengths of the sides, however we can move it on the X and Y plane. And the best way to do this is perhaps to just center it. So I mean you could, so this is the center point, this one here, so we can always do things against the center points. We could click the 2 points there and there and set that to 60 millimeters, and it will keep that in the center. But the better tool is to use this centering tool here. Do the line instead. Centering tool, that's it. So that's defined that. Now, what I think it's done, it said we've got some redundant constraints. Now, as well as having to define the constraints very accurately, it also doesn't like you having more constraints than is needed. It just wants to keep it to the bare minimum. That's to prevent it having conflicts in future. So we can have a look which ones. So it says remove constraint 5. Constraint 5 is the parallel one, the horizontal one. That was added automatically. We don't need it anymore. So that's it, that's gone. And then the same for, if you see now, we've got still 1 degree of freedom, so it can be moved up and down. If we click that line, and then that point there, and center that. And then remove constraint 6. Same. There we go. So you can see now that it's placed in the center, and there are dimensions. So this will be basically our baseboard. I'm going to return now, close that, and we go back into the 3D view. There we go, it's zoomed in a bit too much. So now we can see this is a 2-dimensional rectangle in our 3D view. And we're going to, we need to, the easiest way to select the sketch there, and then pad. This is the pad tool. And pad means basically to raise it from a 2-dimension to a 3-dimension. And we're going to go for 3 millimeters, which is the depth of the baseboard too. And now we can have a look around, and you'll see that it's a 3-dimensional thing. So zoom in and out using the middle roller of your mouse. But to move it, there's different navigation styles, and it defaults to CAD. And to do, it's kind of counterintuitive, but you press the center button and the right button, and then it allows you to turn it around in 3 dimensions. So there we go, you can see, and it's just a plain board. So I'm going to do various things on here to create the effects we want. You can straighten it up, I don't know. So I've clicked the surface. Now I've clicked the top of the surface so that I can then edit on that. What I'm wanting to do here is to sink it down a little bit to basically a millimetre down, so we've got the position of the breadboard fixed. The breadboard will actually be stuck in place using the self-adhesive that's on the bottom, but this will help position it properly. And we're going to start by creating another sketch. So if we go, there's various ways of doing it, but there's the sketch icon. Now, although what I'm wanting it is essentially a rectangle, it's going to have some little points jutting out, which is where you're able to join multiple breadboards together. So rather than doing a rectangle and then adding these, what I think I'll do is to demonstrate it using multiple points, and I'll just roughly draw what I'm trying to achieve and then use the constraints to force it into the correct sizes and everything. So it's going to have a straight line down and then across. So there's a couple of little notches here. Now these are definitely in the wrong position, but that's not a problem, because when we start putting the constraints in, you'll see how it should be. And this is actually going to be really useful, because we'll get to do a number of constraints. Hopefully by the time I've finished putting all these constraints in, you'll have a good idea of how we can use them. Make sure we finish that. And then just right click to unselect that. So clearly that's not quite what we wanted. And sometimes it automatically puts a vertical and horizontal constraint. It hasn't quite on here, I mustn't have been quite. So if we do these, you'll see that it sort of starts to straighten up. I won't put them all as being that, because I use some different techniques. So the top dimension I'll define first. So that should be 83 millimeters. This is something I've just measured it myself. And this one should be vertical, and it should be 54 millimeters. Oh, I mistyped there, so you can just double click and change it. Didn't have my num lock on. Okay, so there's the gives you the main idea of the shape. You see this one is sloping up. If we just turn that onto horizontal, that will keep that horizontal. And the distance, I want this distance, I want this to be 54 millimeters. So do that. And as you see, it's really twisted that up. So actually I'll just remove that for now. I'll just Control Z, usual undo, and what I'll do is we'll just move these so that they're a bit more sensible. Now you could have just gone with it when I did that all wrong and kept adding the constraints until it was right, but it just gets a bit confusing like that. So let's try that again. Right, so let's define that as horizontal for a start, and then set a length of that line to be 51 millimeters. You can see some of these still need to be moved around a bit. That's fine. So what we want to do is to say that that and that should be in line. I could just I could either put that as being a vertical line, that would work, or I could put these two and say I want them to have a horizontal distance of 0. Exactly the same, just different ways of representing that. And then this wants to be 3 millimeters. And if I do that as a horizontal line, sorry, a vertical line, that will stay vertical. And then also need to do just use the roller wheel to zoom in. Set that to be 2 millimeters. And set that to be parallel, to be horizontal. And there we go. So as you can see, even though I haven't defined some of these, it sort of brings them back in. I can use the equality rule. So if I choose those two and click on equals, it'll keep those two the same length. So that's another way of doing this. Now, because that's set to equal and that's set to horizontal and that's set to horizontal, then these are all in line. So now it can move across. Use the middle button just to drag it across. And then we want to do the same here, so effectively we could set that to vertical, give it a distance of 2 millimeters, set that to horizontal, set that to be equal to 1. Then set that horizontal and vertical, for example, and just keep going round. So again, that should be, and as you see, as we keep adding these, the degrees of freedom keep going down, and we need to keep doing this until we've got 0 degrees of freedom. And really it's just a case of using whichever's most convenient at the time. I need to select the other second. Oh. Whichever is the most convenient things to use. And as well as you don't have to just do it on a single length. Here I'm going to do that to that. Should have a distance, vertical distance of 42 millimeters. This is vertical. If I move that there. See, there's that in between that and there. So there's lots of options for what constraints you can be applying. And it just, as long as you are consistent, then they'll all come into line. So you see we're down to 16 now. This length. So here you see what has happened is just it's created them to be overlapping, so I've just dragged them apart to make it a bit more sensible. It should be horizontal or vertical. So that should be 3. You can do that, should be equal to that. No, I won't do that. Try it against that to that. So sometimes so if I said that's that, I think I need to put that as being horizontal first. There we go. So down to 9 degrees of freedom. So you start to think, oh, I'm starting to get it all done. You can just try dragging and see how much. So it looks like we haven't fixed the position of the bottom one. We know we haven't done that and that. So that's also, yeah, that. This needs to be fixed as well. So I've actually got that dimension. So I've got 42 plus 6. I do some calculations here, so I know I've got 42 is the distance between the two notches, plus 3 millimeters for each one is 6, is 48 out of 54, leaves 6, so that should be 3 millimeters. So this length here should be 3. And then I need to position this in the center. So as before, we can use the center point. So if we use that line as the center to just zoom in until I can actually click on there. And if I choose the center, so it doesn't like that because I've got some constraints that are conflicting with that. So quite a useful thing, because we can have a look, see what these constraints are. So there's 5, 6, 7, 8, which are the point constraints. Probably not one of those I need to get rid of. 30, 40, 41. So I'll get rid of that. No, because I want to keep that horizontal, so that 40. That helped. Okay, so that seems to have helped there. Oh, that's no, I'm still. So let's just. So this isn't actually tying this down at all, so that doesn't appear to have worked. So let's try that one again. So it should be from there to there to there, centre. It doesn't work. No. So let's try. I can do the distance between there and there. So if I know it's 51, I want it in the centre, so I can just go for that to that. Horizontal distance of 25.5. Okay, that's a better way of doing it. And that's somehow got twisted, so let's set that a distance of 3 millimeters. Make that vertical. That horizontal. There we go. So how many constraints? 5 degrees of freedom. So we fix that. The whole thing can move up and down and left to right. And looks like there's something going wrong with this here. I haven't tied that one down. Let's try centering that on there. Now, so that the centre, so it's symmetry one rather than centre, doesn't seem to work very well. So better off doing 41.5 between there and there. So looks like this somehow got flipped in, so that's not tied down at all. So that should be 3 millimeters. We can start with that, and then that wants to be horizontal. Okay, so it starts to look better. So the whole thing can still move up and down. So we'll do that to that again. Vertical distance between there, which should be half of the 54, so 27. And then one final degree of freedom. So unfortunately it doesn't tell you where that freedom is, so you have to just keep moving things around until you can find them. Anything that is constrained you won't be able to move, so let's look at that. It's now 3 millimeters. There we go. So this is the one. So if I just do that, let's select them both first. Do that being equal to that. If I just set that as a length. And there we go. So fully constrained sketch. As you can see, this was quite tedious to do, and unfortunately that's one of the downfalls of using a tool such as FreeCAD. On the other hand, there's certain advantages to doing this. It certainly makes it very accurate. Once it's defined, you can move it around and things like that, and it makes it so it's possible to update afterwards. I just realised I have made one mistake here. I've placed that in the centre. I didn't actually want that towards the bottom. So if I get rid of this constraint, which is this one, certainly one of the challenges is when you've got so many different values, that's the one. So I could just delete that as a constraint. There we go. So we introduced a degree of freedom. I actually want it to be down here, and I want the distance from this edge. Now, because this is a different object, we're doing a new sketch, and this is the object we wanted it to link to. We can't do it directly. However, there is a tool as part of the constraints. Oh, there we go, it's up here. This allows you to link to an external geometry, so it's going to allow us to link. I'm going to choose this line here. Now if I want to do anything relative to here, then I can do so. So in this case I'm going to go, I want use the point to be a certain height from that point, which is 20 millimeters. There we go, because I wanted it closer to the bottom than it is towards the top. Okay, so close that. The sketch isn't showing, but it is there. I'm just going to save it at this point. Make sure I don't lose it. So the opposite of pad is to create a pocket, and pocket can be a hole. See, by default it's pushed a hole all the way through it, but I don't want it to go all the way through. I just want it to go 1 millimeter, and it's created a pocket, so a indentation. So if you look at it in 3 dimensions, you can see it's sunk in. So when we put the breadboard on top, it should fit in there just right. So the next thing I want to do is to put the holes to be able to place the banana sockets for connecting to a power supply and such like. I wanted them to be on this face as we did before, so create a new sketch on this face. I'll zoom in because I've wanted to do this. What I'm wanting is, it's actually a circle, but it's got 2 flat ends on it. Now you can create a what is it, effectively like a rectangle with rounded ends, but this isn't quite what I want to achieve, because it will it needs the flat ends to come in. So we're going to do this manually, and it'll show you how to use the manual drawing tools as well. So we'll start with just a line. And I'm going to have an arc. Now I need to put the centre there, and then its start point from there to say there. And we're going to have to define these when we start putting the constraints on. The centre should be the same point. I will not be able to get that to reach there. That's fine. We can sort that out in a minute. That's kind of roughly the shape I'm wanting to achieve, but not quite. So start by start with a circle. So it's actually the arc. So this is the circle tool, and this is to define the radius. I want this to have a diameter of 7 millimeters, so it's a radius of 3.5. It's not straight, but I'll worry about that in a minute, and I'll do the same on here. Then I'm wanting this point and this point to be the same. Now, always tempted to try and click that, which is wrong because this is part of the drawing tools. It looks almost the same, but this is one of the constraint tools. That's it. So that joins that and that. Do the same there. And the last one. There. Now, if I design, set those both to horizontal, and the distance between there and there should be 6 millimeters. And then if I set that equal to that, that should be about right. Oh, that's still 4 degrees of freedom. Yeah, so actually that can twist around. So that these two center points should be the same. There we go. That's what I was trying to achieve. You can see it's it's a circle with diameter of 7 millimeters, radius 3.5, but it's got these two flat bits on, which are 6 millimeters apart. Now I need 4 of these, and as you say, it's just taken a couple of minutes, but really we just need to copy that. I have, see, it's still got 2 constraints of freedom. That's fine. That's up and down. So once I've created all my copies, I can define that. So it's not as simple as just using the copy and paste. You see they're disabled. So it's under Sketcher Tools, Sketcher Tools, and then you can copy and paste, or in this case I just want to clone. Use this one, and then it's showing you what position you're going to do relative to the other one. There we go, and we'll do the same again. I wanted to get 4 of these. Right, so there's our 4 things. So just set the horizontal distance between them to be 0. Keeps them all in line. And then, as before, I'm going to do them. I can just do them relative to this line rather than, I don't have. Oh, I do need to go against this edge. I need to now set that distance, don't I? So remember, I need to do an external constraint, which is that one, and then do distance between. Between there and there. 12.5. And then just distance between the horizontal line to there should be 10 millimeters. And then there to there, 20 millimeters. Let's try duplicating this one again. Oh, let's try the first one, since that was the. So that's fine. That's got 2 degrees of freedom by the looks of it. Let's pin this down before we start doing the next one. that's better. So I'm not sure what happened the first time, but if we do this, okay, so that's what I was hoping to achieve. So 4 cutouts that are going to be on. We've got fully constrained, so we can close that, and there they are there. And what we can do is turn those into holes. So there is a hole option. It's a bit more complicated. It involves you can create things like threaded holes and stuff like that. So we don't want that. We really just want the pocket as we did before. You can put dimensions, or just choose through all. It will make sure that hole goes all the way through. And there we go. So that's that bit done. Now, looking at this, I've decided actually there's probably a bit more spacing than I need. This big gap here, don't really need that. So we can go back and edit anything. So let's go back to the very first sketch, which, if you remember, was just a rectangle, and decided I don't need that to be 110. We'll go for 100. And as you can see, everything's been updated, and that probably looks okay. Last thing I need is 4 holes around the outside, which are going to be used for mounting the legs. Now, sometimes you just get stick-on legs on the bottom and things like that. I find they can be a bit unreliable, and plus that it's going to give me an opportunity to demonstrate how we can create the legs. Now, I just want to make these so at least 8mm in from each corner. I'm going to go for 10mm from each corner. I'm just going to do a very simple hole. So again, as we've done with all these, it's just a sketch. We chose the same face, and I'm just going to draw a circle. I'm going to do these all individually because they're easy enough to do. First click for the centre point, and second click once you determine the radius. And I'm going to set there. So use this circular constraint to set the diameter. These are going to be 1.1. So it's going to be an M2 screw. So it's quite small. And then it's just a case of positioning them. So I want to use external edges again. So I just need to use 2, so if I just use these left and bottom ones, I can then do distance between that and that. Set it vertically to 9. Oh, I think I said I was going to do 10, wasn't I? So 10, and then the same horizontally. And then I could do the same here, or I could just do it in reference to that. So I could do that is vertically at the same height as that. Oh, it's the same height. Oh, there we are. So the advantage of that is that if I move this, that would move with it. It's whichever is most advantageous. Unfortunately, you don't really know when you create them whether you're going to want to resize things or not. So really it's just a case of go with the flow, and when you've got it, if you need to change it in future, just change which constraints you have. As you can see, they don't need to be near to each other, they can be a long way off, and we could even do that to that. There we go, so they're all fully constrained. And again, I just want to create a hole. So using the pocket rather than the hole. Show you the hole tool while I'm here. As you can see, it's got lots of options. You can do countersunk, you can set depth and dimension, but because I've already set the dimensions, I can just stick with the pocket. See, 5mm, because this is only 3 meters, is going to go all the way through anyway. You could do, but just do 3 roll. There we go. So there's a base with holes for mounting some legs, and the banana sockets can go on the top. Now, could leave it like that, but just a nice little feature. Just, I think it looks nice with some nice little round corners. And so when you're in 3D mode, we're back on the part design. You've got all these. You can add fillets, which is what we want to do here. It's a nice curved edge. You could create chamfers or various things, and if you did them on the inside, you'll get them on round in the insides as well. Just click that and then choose a dimension. 2mm. It's quite nice, nice reasonable corner there. I'll just do that on all 4 corners. And there are of course lots and lots of other things you can do. This is only covering some of the very basic tools for creating this. If you look in 3D designs, what you can do is you can create multiple 3D designs and do multi-transforms, mirrors. You can various things. If you switch to, I think it's part design, you can make basic shapes. Sorry, part instead of part design. So part design is where you're wanting to create a part from a sketch that you pad or extrude into the 3D object. Here in the part, you've got some basic shapes that you can use as well. But the bit I want to show you is these. If you've got to 3-dimensional objects, then for instance, if I just, there we go, I've just created this cube. So just for illustration purposes, if we had this that goes through like that, then you can do things like you can subtract it you can, well, so you can do things like create a union, they become the same shape. You can subtract it, or things like that. That will only leave the intersection, so the bits where they overlap, and there's various other things that you can do. But I really just want to get rid of that. So this is it created, and then the next step is to just export it as however you want, and mostly you'll be wanting to say export it as an STL file. The important thing is you have to select the latest objects that you've created, so it's this bottom one that you want to select, and then export, and then you can choose STL file if you're wanting to send it to a 3D printer or various other formats. So that covers this basic shape. The next thing I want to do is create some feet, and these have to be quite high because of the length of the banana plug terminal that goes down underneath the board. So I'm going to use a completely different technique for this. I'm going to use a revolve technique, which is quite common. I'm not going to try and do it on this same design, so I'm going to create a new design as part of this, and I'm going to use we'll go back to use the part design. Right. I'm going to create a sketch, but instead of doing the XY plane as we did before, looking from the top, I'm going to look from the side using the XZ plane, so that's looking from the front. And now what I'm going to do here is imagine I've got the approximately cylindrical legs, and imagine I've sliced through them, and I'm going to draw that around here, but I'm only going to draw one side of it, and then it'll revolve to make a full part. It'll all come together at the end, and you'll see what I mean, but at the moment it does sound a bit obscure. So I'm going to start, I'm just going to use the freehand polyline tool here, and imagine this is our center line. So I'm going to start, and this is going to be the screw. Hole would go there. I'm going to put an area for a countersink for the head of the screw, and then that's the base, and up to there that's the top, and that's roughly the shape. I'm going to make some slight changes here, and it's all going to be done using the normal constraints. So let's start with just right click to cancel that. Use the dimension tool to set distance between there and there, which wants to be about 1.1 millimeters, and that wants to be the vertical line. So this is the countersink, which I think is 3.2 millimeters. I think that's from. So the distance for the countersunk, I want to hide the screw head, wants to be about 2.5 millimeters. Remembering this is the half that the size, so it'll actually be 5mm once we're revolved. So that vertical. Oops, no. And then we want a distance about 4mm there. It's not so. I mean, one of the things with this is that when you don't want to be precise, you don't have that option of where you can just fix the positions where they are, but you sort of have to be very specific. 4mm, yeah, that's going to give us about 14mm total diameter roughly. Then distance of that. So I think this is on top of 2mm. 6 make 8 make about 16mm, which is quite right. So as you can see, I've just got a little bit of a slope just to give that slight tapering down of the leg, and really that's it. I do need to just add a couple more constraints. I think we've just got the 5 degrees of rotation, so I guess it's, if we did the height from there to there, and it doesn't matter what height I do because it's not really relevant, because this is just going to be the one object, 4 degrees. So I haven't, if I just did that as horizontal, oops, wrong one. So what can I move? That's already horizontal. So okay, so the height of that needs to be 3mm. One degree freedom. Yes, so the total height is from there to there. Probably about that actually, 18.5 say. Yeah, 18.5. That's slightly higher than the posts come down, so that should give us. And that's it. So we're fully constrained, and it doesn't look anything like the end result. You have to sort of imagine in 3D revolving this. The important thing is that everything has to stay this side to one side of this line, because then as it revolves around there won't be any conflicts, because it won't like that. If you put anything on this side, then that's going to just break it. So close that, go back and just change the view. There we go. So this is the bottom, this is where the screw is going to go. Select this, and then we're looking for this revolve tool here. And that's it, that's exactly what I wanted it to do. So you can choose whether, because I chose it so that the vertical axis would be where it would revolve around it. It's actually the base z-axis is the same thing. And just click OK. Okay, so that's our leg, and you can see it tapers down, and then it's got an insert for the screw to go in, so that's fully hidden, and ideally you'd want to like a little rubber circle to go across the bottom or something like that, but that's it. Once again, just save it, export an STL, and then 3D print it. And there we are. I've 3D printed that. I've 3D printed 4 of the legs and the board. Fastened them together with some screws and nuts, and fastened the breadboard on top and the 4 banana sockets for connecting to the power supplies, etc. So hopefully you found that useful. So that was a quick introduction to FreeCAD and how you can use it to create shapes. Now with this you can use this to create a board for, say, a robot. I've done something similar. I've done a board for mounting a Raspberry Pi and breadboards and motor controller boards on the same board, various things like that. They're all on my website, penguintutor.com, and I've got various videos on my YouTube channel. So if you found that useful, then please share and like the video, and please subscribe to my channel to find out more about various maker activities that I'm doing, whether it be 3D design, electronics, or Raspberry Pi computing type projects. And hopefully you'll find those useful, and hopefully see you again on a future video. Thanks for watching.